Hello class. Today we're going to go ahead and look at right triangle trigonometry. The learning target for today is that you will be able to identify and apply right triangle trigonometric functions. So let's just start off by looking at an example. The Americans with Disabilities Act provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobility disabilities must not exceed a ratio of 1 to 12. This means that for every 12 units of horizontal run, the ramp cannot rise or fall no more than 1 unit. Okay, so remember horizontal is looking from left to right or as the horizon goes, and then rise or fall would be my 1 foot on this example. So it says find the length of the ramp. Well, in order to find the length of the ramp, I'm just trying to find the hypotenuse, or what is across from the right angle. So I can use the Pythagorean theorem because I have two sides. So it would be 1 squared plus 12 squared is equal to my hypotenuse, which is x squared. 1 squared is 1. 12 squared is 144, is equal to x squared. 1 plus 144 is 145, is equal to x squared. Then what I would need to do is take the square root on both sides. So x is equal to the square root of 145. In this situation, it's a real-life situation, so they probably don't want you to simplify it using radicals. So just go ahead and actually on your calculator tell me what the square root of 145 is. So x is 12 point, and let's round to 3 decimal places all the time. So 12.042 feet. That is how long the ramp is. The next part wants us to figure out, well, what is the measure of angle A? If I'm looking at angle A, the way I'm going to figure that out is by using trigonometry, sine, cosine, tangent. So just remember, SOH, CA, TOA. Okay, if I'm looking at this angle here, my opposite is 1, and my adjacent is 12. So my opposite side and my adjacent, that's who I have. Who uses opposite and adjacent? I see that tangent does. So it's tangent of the angle, we don't know it, we have it labeled A, is equal to my opposite 1 over my adjacent 12. Now in order to solve for A, to actually figure out the angle, I would do A is equal to tangent inverse of 1 over 12. So you would go ahead and do this on your calculator. Biggest thing to remember when you're using your calculators, though, is we want to put this in degrees. So if you're going to use this and we want to do it degrees, go to mode and make sure you change your mode to degrees. Notice how I am in radians. So I would go down, and it's flashing on radians. I move it to the right onto degrees, and then I will go ahead and hit enter. And now I'm in degrees. And to get out of this screen, I will go second quit. And now I'm all ready to go. So on my calculator, I can go ahead and type tan inverse of 1 over 12. That's going to give me my angle. Notice that tan inverse is above tangent, so we're looking right here on this calculator. Okay, so I'm going to go second tan inverse of 1 divided by 1 divided by 12. Let's change that to 12. And hit enter. And so this tells me that my angle A is equal to 4 point, and I'm going to round to 3 decimal places. So I look at this 3, that's the place I'm going to round to. This 6 tells me I need to go up. So it's 4.764 degrees. 4.764 degrees. So I'm going to go ahead and put that on my note sheet. So A is equal to 4.764 degrees. So, thinking back to what we've learned in geometry, you can find missing sides or angles of right triangles using 3 trig functions: sine, cosine, and tangent. So, just to remind you, the abbreviations. The abbreviation of sine is SIN. The abbreviation of cosine is COS. And the abbreviation of tangent is TAN. So, the trig functions. The first one we want to look at is sine. Okay, remember that sine is your opposite over your hypotenuse. Okay, your opposite over your hypotenuse. And so in this case, if it's saying sine of A, that means I'm just looking at angle A. Okay? This tells me I'm looking at angle A. So here's the angle I'm looking at. Who's my opposite side? This is my opposite, so it is A over my hypotenuse. Remember, your hypotenuse is always across from your right angle, C. Another thing to know is that typically they always have the hypotenuse, which is across from your right angle, and then the other two sides that are not, they're called a leg, okay? They can either be the adjacent or the opposite, just depending on which angle you're looking at. But the hypotenuse will always stay the same. Now let's go ahead and look at cosine of A. So if I'm looking once again at angle A, cosine is adjacent over hypotenuse. Well, this is my opposite, because it's across from the angle. My hypotenuse is always across from the right angle, so that means B is my adjacent. So cosine of A, adjacent over hypotenuse. My adjacent is B over my hypotenuse, C. And lastly, tangent. Tangent is opposite over adjacent. My opposite is A. My adjacent is B. So it's A over B. And just remember, so, TOA. Okay? Remember, it is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then what's a reciprocal? Well, a reciprocal is when you take and you flip something. So if I have a fraction 1 over 2, the reciprocal is 2 over 1. So these are just the reciprocal functions of my tangent. So cosecant is really the reciprocal of my sine. Well, it's really going to be just flipping A over C. So now it is C over A. Another way to think about it is it's really 1 over sine of theta. Okay, secant is the reciprocal of cosine. If you notice, it's hypotenuse over adjacent. So it's really C over B, or another way is 1 over cosine of theta. Okay, sorry, not theta, be A, because we're talking about angle A. Theta is another term we use for angles, but we have angle A still. So it's cosine of A. And then adjacent over hypotenuse. Sorry, cotangent is the adjacent over the opposite, which is the reciprocal of tangent. So now it's going to be B over A, or it's 1 over tangent of A. Okay. So example 1 says find the values of the 6 trigonometric functions for the angle theta. Okay, so we need to find sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. So if we're looking at theta, what I would just do is go ahead and label what everything is. My opposite is 4. Okay, my hypotenuse is always across from my right angle. And then lastly, my adjacent. Adjacent means next to, so it's next to the angle. It's the one that's not the hypotenuse. So sine is opposite over hypotenuse. So I have 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. And tangent is opposite over adjacent, so 4 over 3. Now I just need to do the reciprocals. Well, cosecant is the reciprocal of sine, so it's sine is 4 over 5, so this is 5 over 4. Secant is the reciprocal of cosine, so that's going to be 5 over 3. And then cotangent is the reciprocal of tangent, so it is 3 over 4. Okay. Before we go ahead and flip to the back side, if you'd like to pause, now would be a great time to pause, take a break. Remember, if you need to, you can rewind the video and rewatch anything that you need to. Also, if you have any questions, please write them down now before we continue on. Okay. You can ask them tomorrow in class. Okay. Example 2, if cosine of A is equal to 2 over 5, find the value of tangent of A. Well, remember that cosine is adjacent over your hypotenuse. So if I just draw myself a little triangle, and I'm going to label this angle A, well, cosine of A is 2 over 5. So really, it's my adjacent is 2, So my adjacent is 2, and my hypotenuse is 5. I want to find tangent, so I need to know my opposite. I have a right triangle. I know two sides, so I'm going to use the Pythagorean theorem to find side A. So I have 2 squared plus a squared is equal to 5 squared. So this is 4 plus a squared is equal to 25. I would subtract 4, so a squared is equal to the square root of 21. So a squared is equal to 21. Sorry, jumping the gun a little bit there. So this is 21. If I take the square root on both sides, a is equal to the square root of 21. So this side here is equal to the square root of 21. Now if I want to find tangent of a, tangent opposite over adjacent. My opposite side is the square root of 21. My adjacent is 2. The square root of 21 over 2. That's example 2. Example 3. It says find tangent of B. If tangent of B equals 3 over 7, find the value of sine of B. Same idea here. I'm going to go ahead and draw myself a triangle. Tangent, okay, tangent of B, I'm going to label this angle B. Tangent is opposite over adjacent. So now in this case, I know my opposite is 3, my adjacent is 7. I do not know my hypotenuse, so I'm going to call it x. So I'm going to solve for x. So I would have 3 squared plus 7 squared is equal to x squared. This is 9 plus 49 is equal to x squared. 58 is equal to x squared. Then I would take the square root on both sides to get x. So x is equal to the square root of 58. There is no perfect squares in there, so we're good. Now I need to find sine of b. So sine is opposite over hypotenuse. So my opposite is 3 over my hypotenuse, square root of 58. Except for it is not simplified all the way or proper to leave a square root in the denominator. So what I need to do is multiply by the square root again. Square root of 58 over the square root of 58. Square root of 58 over the square root of 58 is really 1. You can multiply anything by 1 and it will not change. And so if I go ahead and simplify, I would have 3 times the square root of 58. And also the square root of 58 times the square root of 58 will give you 58. Okay. So there it is, all simplified. There is my sine of b. Example 4, we need to solve for x. So I'm given that this angle is 20 degrees. So I have my opposite and I have my hypotenuse. Okay, well, who uses opposite and hypotenuse? Sine does. So I would use sine of 20 degrees is equal to opposite x over hypotenuse 15. I would go ahead, to solve for x, I would multiply by 15 on both sides. So x is equal to 15 times sine of 20 degrees. So once again, on your calculator, we're going to go ahead and type this in. Okay. So we would do 15, so type 15 times, and we're going to do the sine of 20. So sine is right here. So sine, and then you type 20. Make sure your calculator is in degrees. So sine of 20. And the parentheses, and go ahead and hit enter. So we get that sine, 15 times sine of 20 is 5.130. Okay, round to 3 decimal places. So this, we're looking here, this tells me that I'm going to stay the same at my 0. Okay, so there's my answer. So x is equal to 5.130, and x, it does not give a label, so it's just 5.130, and you could use units if you want it. All right, moving on to example 5. It says solve for triangle XYZ. Whenever it tells you to solve, it means find the values of all the sides and all the angles we don't know yet. So let's start with maybe one of the easier things. we know that this means it's a 90-degree angle. Okay, so I need to find this angle here, angle y. Okay, well, angle y, I know all of my angles in my triangle add up to 180 degrees. So I would have 35 degrees plus 90 degrees plus angle y is equal to 180. If I go ahead and add these together, I get 125 degrees plus y is equal to 180 degrees. And then I would subtract 125 on both sides, and so I get y is equal to 55 degrees. So that is all of my angles. Now I need to go ahead and find my sides. I need z and I need x. Okay, I recommend using the information already provided. So let's go ahead and find x first. If I have my angle 35, I have my opposite and my adjacent. So who uses opposite and adjacent? Well, tangent does. So it's tangent of 35 degrees is equal to my opposite x over my adjacent 10. To solve for x, I would multiply by 10 on both sides. So I would have that x is equal to 10 tangent of 35. And if you type that in on your calculator and round to 3 decimal places, you get 7.002. Okay. So x is equal to 7.002. Now we would go ahead and we would solve for z. Z is the last thing we need to solve for. If I have this, I know that this is my hypotenuse. Here's the angle that I have, and I'm also going to use 10 because I was already given that. So I have my hypotenuse and my adjacent. Well, who uses your adjacent and your hypotenuse? Cosine. Cosine of 35 degrees is equal to 10 over z. Okay, so we want to solve for z. So first thing we would do is multiply by z on both sides. So I have z times cosine of 35 degrees is equal to 10. Now, in order to get z by itself, I would divide by cosine of 35. The cosines of 35 will cancel, and so z is equal to 10 divided by cosine of 35 degrees. And if I type that in on my calculator, I would get 12.208 is what z is equal to. Example 6, in order to construct a bridge, the width of the river must be determined. Suppose a stake is planted on one side of the river directly across from a second stake on the opposite side at a distance of 50 meters to the left of the stake. An angle of 82 is measured between the two stakes. Find the width of the river. Well, our picture lays it out very nicely, but we're trying to find the width. I have this angle. Okay, so I always go off the angle I'm given. So that means I have my opposite, and this is my hypotenuse, so this is my adjacent. So I want to use my adjacent and my opposite. Who uses opposite and adjacent? Well, tangent does. So it's tangent of 82 degrees is equal to my opposite, w, over my adjacent, 50. To solve, I'd multiply by 50 on both sides. So w is equal to 50 times tangent of 82. So type that into your calculator, and you should get that w is 355.768. And I should label this meters. So the width of the river is 355.768 meters. And our last example. John found two trees directly across from each other on the canyon. Okay, so 2 trees. They're directly across from each other, so here's the canyon. Directly across from each other on the canyon. When he moved 100 feet from the tree on his side, parallel to the edge of the canyon, okay, so he moved 100 feet over this way, the angle formed by the tree on his side, John, and the tree on the other side was 70 degrees. So, if this is where John is, this was a 70-degree angle. Okay. Find the distance across the canyon. So we're trying to find this distance here. So right triangle. So I look at what I have. I have this angle. So it means I have my opposite, and this is my adjacent. So once again, who uses opposite and adjacent? Well, tangent of 70 degrees is equal to my opposite, D, over my adjacent, 100. So I would go ahead and multiply both sides by 100. So 100 tangent of 70 degrees is equal to D. And if I go ahead and type that in on my calculator, I get 274.748 feet. Okay. So please go ahead, write down any questions you have so that you can feel free to ask me tomorrow in class. Other than that, we will go ahead and you're going to work on the right triangle trigonometry worksheet next. So have a good day, and I will talk to you later.